Do you know what molecule this is? What compound is that? Water. How do you know that's water? How do you know that that's water? It's got two H's and one O. And you know, two H's, one O is water. So the proportion or ratio here is 2H, 1O is always water. If you change the number of atoms, you change the name of the compound and you change the identity. H2O2 has two H's, two O's, so it's not water. Right? It's not water because there's one too many oxygens. This is hydrogen peroxide. This is hydrogen peroxide. There's one hydrogen per oxygen. Hydrogen peroxide. Do you know what this is used for? Cleaning stuff. Yeah, this is good for cleaning wounds or cuts. And it's also added to some detergents or spot detergents because it eats away at the stains, anything organic like grass or food. All right, so law of definite proportions. So sodium chloride will always be NaCl. Water will always be H2O. Carbon dioxide, always CO2. Percent composition. The percent composition, the percent by mass, the percent by mass of each element in a compound. One carbon divided by the mass of the entire thing, 16.05 times 100%. And this will give you the total percent carbon. So the total mass of carbon is 12.01. The total mass of hydrogen, 4.04. With me?
Just write this on the slide.
Well, oh, you know what? I see that I gave you space for each of it. You've got total mass of carbon. Right, 12.01. Total mass of hydrogen. Right, 4.04. Total mass of the entire compound, add them together. We won't do it so stretched out. So with the percent carbon, you're going to take 12.01 divided by 1605, times it by 100. To figure out the mass, the percent of hydrogen, you're going to take, this is percent carbon. Percent hydrogen, you're going to take 4.04 divided by 16.05 times 100%. So somebody with a calculator? Yeah, they should add up to 100. So if you've only got two elements, you could take the first percent away from 100 to give you the other. Okay. Like this, it'll make your percents easier. So we're going to find the total molar mass first. What is the molar mass of potassium? It's K. Got it, Dakota? It's the number at the bottom. Got it? 39.10. So 2 times 39.10. So that's 78.2. Okay. Hussein, what's the molar mass of sulfur? It's near the right somewhere. Near oxygen. 32.06. Alyssa, what's the molar mass of oxygen? 16. Okay, we add all of those numbers up to get the molar mass of the entire compound. Am I right? That's how you figure out percents. Pretty straightforward. Figure out how many they are of that atom, times it by the mass of one atom, divide it by the total mass of everything, multiply it by 100, and you're good.
Wait, it should have been 18.4.
18.4? Okay. 4, 0?
Yeah, 4.
Okay, well, we're close. Thank you, though, for checking. Okay, so that's percent composition. Do you guys think you were okay with that, or do you want to do another example? So, or you're good? All right, empirical formula. Empirical formula, the lowest whole number ratio. Of atoms. It doesn't tell you how many atoms there are, but it tells you the ratio. Okay. Write these down at the top of the page, above empirical formula, but leave a space between them. H2O2, C6H12, C6H6, and CO2. These are molecular formulas for the compounds. This is what the actual compound structure is. What we need to figure out is the empirical formula. So the lowest whole number ratio. So you see, can you reduce the numbers at all? And to reduce the numbers, a number has to go into both of them. So for H2O2, what could you divide both?
1, 2.
By 2. So then the empirical formula would be HO, because we divided by 2. What would the empirical formula for C6H12 be?
CH2.
Yeah, CH2, because you can divide both of those numbers by 6. 6 divided by 6 is 1. 12 divided by 6 is 2. How about C6H6 then? CH. And how about CO2? Can you divide that? So that's already in the lowest possible form. So the empirical formula is the same as the molecular formula. Moles of iron is the mass of iron divided by the molar mass of iron. So you got to look that up on your periodic table. So you take the percent in grams, divide it by the molar mass of iron. Can you find iron?
Is it 5.85?
55.85. Thank you. The moles of oxygen is the mass divided by the molar mass. So 69.9 divided by 55.85. Dudley, what'd you get? Yep. Angelica, what'd you get for the second one, the oxygen?
1.25.
1.25?
Oh,
Is this
1.88?
1.88?
Yeah.
Beautiful. Okay. Which one of those numbers is the smallest?
iron.
What's beside the M?
Oh, sorry, the symbols for the element, Fe.
Oh,
Sorry, F, E, and then the O.
yeah.
Okay. So what we have to do now is figure out the ratio. So you divide by the smallest number. So this would be 1.25. So the one that you're dividing will end up be 1. What is the other one? 1.50?
504, yeah.
Thank you. Now we have a problem here. Oh, I'm going to take out that 0. Can you have half an atom of oxygen?
Yes.
No, can't. Can't cut an atom is the smallest thing you can have. What would I have to multiply 1.5 by to make it a whole number? 2, you got it. So multiply both of these numbers. Oops. Multiply both of these numbers by 2 so that you get a whole number.
Wait, so 1.88 divided by 1.25 is 1.5?
Yeah. So then we end up with 2 Fe's. Oops, sorry, that disappeared off the screen. 2 Fe's and 3 oh, cool. 2 Fe's and 3 oxygens. If you end up with a fraction, you have to get rid of the fraction. So our empirical formula is Fe2O3. That number, the number that you get at this last step becomes your subscript in your formula.
So wait, what goes under determine lowest ratio formula?
That's this part right here. You can keep doing it. You're not going to separate. You're going to do a question like the whole thing. Did you squeeze it all in?
Yeah.
Don't worry about
No,
it.
I didn't.
How far did you get?
No, because I'm at 3 determine mole ratio.
And did you do this part?
Yeah.
So you got 1 and 1.5?
Yeah.
Okay.
And then the part that's in black should be under.
It should be under the lowest, the last part there. So I'm gonna do another example with you, but you're gonna, empirical formulas. Oh, wow, okay. I need to give you an easier one. Okay. Do you think you have enough room on the bottom of the page to do another small example? Or if not, get out another piece of paper. We're going to go through this, but all in one fluid step. Okay. So, a compound is 82.5% carbon, and 17.5% hydrogen. We want to figure out what the empirical formula is. So the first step you do is change the percent to mass. So 82.5 grams carbon, 17.5 grams of hydrogen. So right there, you've got step one. Calculate the number of moles. So what you want to do is you want to take that mass, put it over the molar mass. So this one is carbon, so it's 12.01. This one's 1.01. And do the math. It'll take up less room when you're actually doing the question than doing my example. So what is 82.5 divided by 12.01? What'd you get, Evan?
I got 6.86.
6.86. And what is 17.5 divided by 1.01? 17.2?
32.
17.32. All right. Alyssa, tough question. Which one of these two numbers is the lowest? 6.86. So now you're going to divide both numbers by 6.86, and this will give you our mole ratio.
Does it matter if you round it?
Round it to what?
Like 6.87 and then
No, that won't matter, no. Yeah, you can round off the decimal place. That'll be fine. But you can't round 1.5 off to 2.
no, just move to that.
Yeah,
Like when
that,
you divide them.
yeah, that would be fine. Yep. So how many times does 6.86 go into 17.32? Could it be maybe double? 2.5? Another 2.5? I can't seem to pick ones with... Wow. I was hoping to give you a simple one. Okay. You can't have half of a hydrogen, so you have to multiply. Anytime you get a half, you have to multiply by 2. If you get whole numbers, or you're off by 0.1, like you can round it off, then you're fine. So C2H5. So your empirical formula is C2H5. Are you okay with that? It's just whether you can follow the steps, basically. 3.03, 16, so the molar mass of our empirical formula is 31.04 grams per mole. It says the molar mass of the entire compound is 93.12. So what you do for step 2 is you take the 93, divide it by the 31. So that's step 1. Step 2, 93.12.
Where do you get that?
It gave you that in the question. It has to give you the molar mass of the compound. How many times does 31 go into 93? 3. So, that is your multiplier. You take your empirical formula, you multiply it by that number, and it gives you the molecular formula. So CH3O times 3 is C3H9O3.